Hello everyone, I am Dr. Sirajul Faizi. I welcome you in my YouTube channel. Today in this video, I am going to talk about some basic concept of chemistry, starting from composition of matter. You know what is matter? Everything in the universe is composed of matter. Matter is anything that occupies a space or has mass. You can see here how the volume transferred into the glasses. Now mass, what is the mass? Quantity of matter an object has. And what is the weight? Pull of gravity on an object. Now, what is elements? Pure substances that cannot be broken down chemically into simpler kind of matter. More than 100 elements, 92 naturally occurring elements, already discovered. So, you can see here the S block element, P block elements, D block elements, and F block elements. You know, my friend, 90% of the mass of an organism is composed of 4 elements: oxygen, carbon, hydrogen, and nitrogen. Here, you can see this is the atomic number, this is the chemical symbol, this is the atomic mass. So each element unique chemical symbols consist of 1 to 2 letters, and first letter is always capitalized. So should be capital. Here any N should be capital. Now what is atoms? The simplest particles of an element that retains all the properties of that element. Properties of atom determine the structure and properties of the matter they compose. Our understanding of the structure of atoms based on scientific models, not observations. So, the nucleus, the central core, here you can see, consists of positive charged protons and neutral neutrons, and positively charged contains most of the mass of the atoms. So, the protons, all atoms of a given element have the same number of protons. Number of protons called the atomic number, and number of protons balanced by an equal number of negative charge, that is electrons. So what is neutrons? The number varies slightly among atoms of the same elements. Different number of neutrons produces isotopes of the same elements. Now what is atomic mass? Protons and neutrons found in the nucleus of an atom. Protons and neutrons each have a mass of 1 mu, atomic mass unit. The atomic mass of an atom is found by adding the number of protons and neutrons in an atom. So, what is electron? Negatively charged high-energy particles with little or no mass travel at very high speed at various distance energy level from the nucleus. So, electron is the same energy at approximately the same distance from the nucleus. Outer energy level have more energy than inner level. So each level hold only a certain number of electrons. You can see the lithium, beryllium, boron, carbon, nitrogen, oxygens, etc. Now energy level. Atoms have 7 energy levels. The levels are K closest to the nucleus, L, M, N, O, P, Q farthest from the nucleus. The K level can only hold 2 electrons, and levels L and 2Q can hold 8 electrons, and octet rule. You know, periodic table elements are arranged by their atomic number on the periodic table. The horizontal rows are called periods and tells number of energy level. Vertical groups are called families and tells the outermost number of electrons. So you can see the periodic table of an elements. So there is non-metals and alkali metals, then transitions metals, alkaline earth metals, and then you can see the other metals have the rare earth metals and halogens and inert elements. So this is group 1, 2, period 1, 2, 3, 4, 5, 6, 7, and group 18, which is divided into N. Now compounds. Most elements do not exist by themselves. Readily combine with other elements in a periodic table fashion. So this is the compound you can see. The compound is a pure substance made up of atoms of two or more elements. The proportions of the atoms are always fixed. So chemical formula shows the kind and proportion of atoms of each element that occurs in a particular compound. Now molecules are the simplest part of a substance that retains all of the properties of the substance and exist in a free state. Some examples you can see: the large and complex. Now chemical formula. Subscript after a symbol tells the number of atoms of each element. H2O has 2 atoms of hydrogens and 1 atom of oxygen. Coefficient before a formula tells the number of molecules. 3O2 represents 3 molecules of oxygen, 3H2 or 6 atoms of oxygen. Now, physical and chemical properties of compounds differ from physical and chemical properties of individual elements that compose it. You can see the water molecules, you can see the oxygen molecules, you see the sucrose molecules. So, tendency of element to combine and form compounds depends on the number of arrangement of electrons in their outermost energy level. So, atoms are most stable when their outermost energy level is filled. So, the most atoms are not stable in their natural state, tend to react combined with other elements in the form to become more stable. The chemical reaction bonds are broken, atoms are rearranged, and new chemical bonds are formed that store energy. You can see the molecules. So, covalent bond formed when the two atoms shared one or more pair of electrons. Ionic bond means some atoms become stable by losing or gaining electrons. Atoms that lose electrons are called positive ion. Atoms that gain electrons are called negative ion. Because positive and negative electrical charges attract each other and a compound form. So, what is the energy and matter? You know, the ability to do work or change occurs in various forms, can be converted to another form. Forms important to biological system are chemical, thermal, electrical, and mechanical energy. Free energy is the energy in a system that is available for work. Now, state of matter. You know, my friends, atoms are in a constant motion. The rate at which atoms or molecules in the substance move determines its state. You can see the solid, liquid, and gas state. What is solid? Molecules tightly linked together in a definite shape, vibrating in place, fixed volume and shapes. What is liquids? Liquid molecules not as tightly linked as a solid, maintain fixed volume, able to flow and conform to the shape of the container. What is gas? Molecules have little or no attraction to each other, fill the volume of the occupied container, move most rapidly to cause a substance to change state. Thermal energy, heat must be added to or removed from a substance. You can see here. Now, energy and chemical reaction. Living things undergo thousands of chemical reactions as a part of the life process. You can see the precipitation reaction. Many are very complex, involving multi-step sequence called biochemical pathway. Chemical equation represent chemical reaction. Reactants are shown on the left side of the equation and products are shown on the right side of the product. And this is the multiple steps. So the number of each kind of atom must be the same either of the side of arrow. Equation must be balanced. So energy transfer. You know, much of the energy organisms need provide sugar, food, undergo a series of chemical reactions in which energy is released called cell respiration. The net release of the free energy is called exothermic reactions. So reactions that involve a net absorption of free energy are called endergonic, endothermic reaction. Photosynthesis is an example. Most reactions in living organisms are endergonic. Therefore, living organism require a constant source of energy. You can see here the progress of reaction. Now, most chemical reactions require energy to begin. The amount of energy needed to start the reaction is called activation energy. You can see the matchbox. So, certain chemical substance catalysts reduce the amount of activation energy required. Biological catalysts are all called enzymes. Now, enzymes are an important class of catalysts in living organism, mostly protein, thousands of different kinds, and each is specific for the different chemical reactions. Now, enzyme structure. Enzymes work on the substance called substrate. Substrates must fit into a place on the enzymes called the active site. This is the active site. Enzymes are reusables. Here substrate, active site, and enzyme. Now, reduction-oxidation reaction. Many of chemical reactions that help transfer energy in living organism involve the transfer of electrons. Redox, oxidation, redox reactions. You can see here the reaction. So, oxidation reaction, reactant loses electron, become more positive. You can see here sodium loses one electron, become the positive. So, reduction reaction, reactant that electrons become more negative, gains. You can see the sodium react with chlorine, if sodium chloride, so Cl2 0 become -1. So what is the solutions? A solution is a mixture in which two or more substances are uniformly distributed in another substance. Then what is solute? Solute is the substance dissolved in solution. Particle many may be ions, atom or molecules. You can see in the picture water and sodium and chlorine. So solvent is the substance in which the solute is dissolved. Water is the universal solvent. Now, solution can be composed of varying proportions of a given solute in a given solvent, can vary in concentration, measurement of the amount of solute. A saturated solution is one in which more the solute can be dissolved. Aqueous solution, water, are universally important to living things. Now, dissociation of water. The breaking part of the water molecules into two ions of the opposite charge due to a strong attraction of hydrogen atom of one molecule for hydrogen atom of another water molecule. You can see the hydrogen ion, hydroxide ion, and forming hydronium ion. So, what is acids and bases? One of the most important aspects of a living system is the degree of acidity or alkalinity. The number of hydronium ion in solution is greater than number of hydroxide ion. You can see here. Number of hydroxide ion in solution is greater than number of hydronium ion. You can see here. pH scale, logarithm scale for comparing the relative concentration of hydronium ions and hydroxide ion in a solution ranges from 0 to 10. So each pH is 10 times X stronger than X. So pH 1 is 10 times stronger than the seconds. So the lower the pH, the stronger the acid. The higher the pH, the stronger the base. And pH is equal to 7 is neutral. What is buffer? Control of pH is very important. Most enzymes function only within a very narrow pH. So control is accomplished with buffer made by the body. Buffer keep a neutral pH is equal to 7. You can see. So buffer neutralizes small amounts of either an acid or base added to the solutions. So complex buffering system maintain the pH value of your body, many fluids at a normal and safe level. So my friends, I hope this video will be helpful to you. If you like this video, then subscribe my channel and thanks for watching.